Yes.
Yeah.
Okay. So let's start with, well, there's a bit of previous things that I've skipped, which is just basic statistics. I believe if you were to learn that at school, it will all come back to you and that shouldn't be too complicated. So I'm more going to do the hard stuff, the things that are not obviously from basic Year 10 statistics. Okay, so the first thing we're going to be looking into is continuous probability distributions. I'm just going to do a bit of reading because this is all going to be new. So when a variable can take any value in a particular interval, for example, when you measure it rather than count it, you say you have a continuous random variable. Quantities which can be modeled using continuous random variables include height, weight, time, and mass. The other one would be a discrete probability distribution, right? Discrete meaning you can count it like how many cars are outside, you would actually say 5. Whereas continuous data can be like decimals, fractions, and so on. A continuous random variable is defined by its probability density function, PDF, in other words. So it is defined by its PDF. You need to know that word and get used to saying that word. Probability density function, which is usually represented by, there's your friend, f of x. So probability density functions are actually f of x. A continuous random variable is defined over the interval -infinity to infinity. Although in practice it is common that the probability associated with much of this interval is 0. As a result, f of x is usually defined as a hybrid or piecewise function. Piecewise as in, it's going to, I mean, if you guys remember piecewise, it's just like it could be, you know, it could be a parabola on this side, and then it could be a straight line from here onwards. So it just depends. But to help understand continuous random variables, consider the following example. Dirk. Dirk travels to work by train every day. He's interested in mathematics and decides to collect some data about the lateness of his train service. Over a 10-week period, which we were going to say is it's 50 work days, he found the following, where 0 is less than or equal to 2, means for 0 to less than 2 minutes late. Oh, sorry, 0 to less than 2 minutes, not less than or equal to. 0 to less than 2 minutes late. So that means if you're 2 minutes late, you're in this section, just so you know that. So 0 to 2 minutes late, frequency 5, which means it occurred 5 times. 2 to 4 and less than 4, but it occurred 15 times, and I think we understand the rest. There, from that, you can work out the total frequency, which we already know is 50. But if you added it up, you would work out a total frequency of 50. Dirk's train service runs every 10 minutes so that a train cannot be more than 10 minutes late. Cool? They can't be more than 10 minutes late. It runs every 10 minutes. If Dirk wants to calculate the probability of his train being less than 4 minutes late, less than 4, well, that would be this and this, because it can be less than 2 and less than 4. So that means he can add together the 5 and 15, so the probability is 20 over 50, which becomes 2 over 5. I think we understand that. This is written as probability, train is less than 4 minutes late, which is 2 over 5. Any questions for me up to this stage? No.
No.
This is a simple calculation, but how can Dirk calculate the probability of his train being less than 3 minutes late? That is something you've never looked into. So you've had it from less than 2 and less than 4, but come on, it's not always going to be like that. What if we want it to be a little bit more fluid? So I want to pick any number in the world and say, okay, what's the probability of it being, like, in this case, less than 3 minutes late? There has to be a way of being able to do that. That is also not biased. So the group data table is not useful for calculations within individual data bins. Dirk thinks a histogram might help, but decides to use the relative probability density values. So in other words, the probability density functions, but I'll explain that in a second, density values for the vertical axis. The relative probability values are found by dividing, there it is, the probabilities by the bin width, which in this case would be 2. So, for example, we had a probability of, we had okay, let's just talk from. So the minutes late, you were from 0 to 2. The probability of that occurring is 5 over 50, which is this one here. 5 over 50, meaning that becomes 0.1, right? That's the probability. The probability of it being from 2 to 4 is 15 over 50, which should give you 0.3. And I think we get the rest. How do I work out the density, the relative probability density? You divide it by how many numbers there are in this width from 0 to 2, which obviously is 2. And that gives you my density of each one, 0.05, 0.15, 0.17, 0.1, and 0.03. This won't necessarily add up to 1, and it doesn't need to add up to 1. Any questions up to this stage? Okay. We'll continue. If you calculate the area of each of the rectangles in this histogram showing relative frequencies, so there it is, they drew it up, like from 0 to 2, there's 0.05, from 2 to 4 it goes up to 0.15, and 4 to 6 goes to 0.17, 6 to 8 goes to 0.1, and then 8 to 10 goes to 0.03. You'll find that their sum is 1. Yes, sorry, the area. I was going to say, what? How? The area, if you calculate the area of the rectangles in the histogram, so you calculate the area here, so 2 times this, 2 times this, 2 times this, 2 times this, and 2 times this, the area must equal to 1. Why? Because, of course, all you've done is you've just gone back into these numbers, right? If you're going to get these numbers and multiply them by 2, you've gone back to the probability. If you add up all your probabilities, it does equal to 1. But in other words, the total area actually represents the total probability of all the possibilities. Now, we know there's another way of working out area, and that's integration. And that's how you're going to link integration to probability. Okay, coming to it soon. Let's keep reading it, why not? Does this help Dirk find the probability of his train being less than 3 minutes late? Obviously not, but it gives Dirk another idea. He decides to model the data using a parabola, as you can imagine a negative parabola running over the histogram, and I think you guys can see that. There it is. Dirk decides that the turning point for this parabola is this, hypothetically, as this represents the median of the time values and corresponds to the highest point in the histogram. This gives an equation of this. Dirk now has to find the value of k. The area under the curve must be 1. So calculus can be used to express the area as an integral. So that means the integral from 0 to 10, all the numbers from 0 to 10, for this new function, which you don't have to worry about too much at the moment, dx must equal to 1. Why? Because we just worked out that we worked out area equals pretty much probability, right? So in other words, the integral must equal to, of all the terms, all the numbers from 0 to 10 of this function must equal to 1. And then obviously you evaluate, you sub in, and eventually you're able to work out that k becomes this, right? I'm just going to pause there. Tell me any questions at this stage. Okay, great. This then gives us the probability density function, that is, the parabola that models the data as. The function is this. It's this, as long as x is between 0 to 10. So, right, negative k, because that was the assumption that we chose, negative k, x take away 5 squared, negative k, x take away 5 squared plus 0.17, as long as it's between 0 to 10, and it's 0 otherwise, because we know that the the probability of these numbers must equal to 1 or 0 otherwise. Okay. Any questions at this stage? That's really important line, that one there. We're not going to do that check.
Sam, can you just go over that again, please?
Yes. So once you've worked out your k value, you now know your function must be this, which is negative k x take away 5 squared plus 0.17 for all the numbers between 0 to 10.
Mm-hmm.
And then if it's outside of 0 to 10, so if it's like 11 minutes or 12 minutes or 13 or whatever it is, it's always going to become 0. It doesn't exist.
Okay.
Because, and the reason why it won't exist, not only because of the parabola, but it doesn't exist because you know that this probability equal to 1. So then everything else outside of this domain must equal to what?
0.
0. That's the idea. We're not going to do the check bit. Okay, so then the idea is once, I mean, it just says, oh, like he's checked it just to see if it's pretty accurate, blah, blah, blah. We're not going to do that because you're not going to make up your own one right now, so don't worry. But then the idea becomes to this, like if you wanted to actually work out the probability of a train being less than 3 minutes late, well, once you know your function, it's just going to be between 0 to 3. So you can actually integrate between 0 to 3. And then you just sub it in, and there it is. So you can actually work out for any number. If you wanted to work out what is the probability that the train is going to be between 2 and 3 minutes late. Well, that would just mean what? From 2 to 3. And then you just integrate it and get your answers out. Does that make sense? Ezra, Steph, does that make sense?
Yeah. Yeah.
That's the important bit. I guess we'll read a few of the notes now that these guys might have written. If x is a continuous random variable, then, okay, if x is a continuous random variable, the probability that capital X is equal to little x equals 0 for all possible values of x. That means the probability is represented by area, so area width results in 0 because you're at that area, there is no width. So there's 0 area, so therefore the probability is straight away 0. So if you ever have that, it's just going to be 0 straight away. The function f is a probability density function. We spoke about that, of the variable x. It is important to know that f of x is not the probability. It is the probability density function. It's the PDF. You need to integrate the two limits to obtain a probability. Okay, so f of x is the PDF, which you have to integrate to get the probability. So you have to integrate the PDF, and that gives you the probability. I think we get that. They all have the same rule. Yeah, I think that all makes sense. That's nothing. Yep, that's nothing. All right, I think we should be able to do this. Here we go. A particular continuous random variable has the following probability density function. Ready? For f of x, it's this, between 0 to 1, and it's 0 otherwise. Find the probability of x being less than or equal to 0.7. Can someone tell me what I'm going to write? It's definitely going to be integral. Less than 0.7. Is it the first one or second one? First one, good. So it is negative 3 x minus 1 squared plus 2 And then from where to where? What do you think, Azra?
Is it from,
What would you say? From?
would it be 0.7 at the top?
So from 0 to 0.7. Do you agree with that?
Yeah.
Because it has to be from 0 to 1 anyways. And then you're just stopping it somewhere at 0.7. And then, I mean, doesn't that look like a straightforward question that you've already been doing for the last few months now? Like pretty straightforward stuff, you know, calculus. Steph, what do you think? Easy?
Yeah.
It's just linking, I guess, integration now with probability. Something you might have not looked at before. In this case, these guys obviously expanded it. That's great. We don't really care about that. But let's just say that you expanded, you integrate, you sub in, you're done. Easy. Easy, easy, easy. Can I move on?
Yeah.
All right, let's try this one. Calculating a value associated with a continuous density function for a piecewise function. Shouldn't be a problem. If you're just following everything I've said, I think we should be pretty sweet. So it says find the probability that x is less than or equal to 4.7. Well, of course, that would go into this top one. So that means we're integrating from 4.5 to 4.7 of this function here. There it is. And you evaluate. Any questions about that?
No. Nope.
And then same thing, obviously, come on, less than 5.2, it's just going to go here. So you know it's going to be from 5 to 5.2. What happened? What am I doing? 4.7, 5.2. Yeah, why? Why isn't it just 5 to 5.2? Oh, silly Sam. Rushing. Okay, this says less than 5.2, right? It doesn't say between, you know, it doesn't say between 5 and 5.2. That would be what I had assumed, which is obviously from 5 to 5.2. Less than 5.2 means what? Means from 5 to 5.2 it's this guy, but then from 4.5 to 5 it's this guy. Do we understand that before I just we go through the answers again?
Yeah.
Yeah, nice. All right. Then here it is. So from 4.5 to 5, it's the first function, and then from 5 to 5.2, it's the second function. And you can see in this case, the less than or equal to is not really relevant as much as it used to be back when you had to do your substitutions. So you're still subbing in 5 and 5 for the two different functions. Okay. If any integral evaluates to more than one of four any probabilities, then you cannot be sure your answer is incorrect. The entire area under the curve must be 1, so part of it cannot be greater than this. Similarly, if your integral gives a negative value, then this can be incorrect because obviously area cannot be negative. The mean of a continuous probability density function is found using the following formula. Okay, good, that's another one. So now, average, or the mean. The mean of a continuous probability density function is found by using the following formula. This is called mu, M-U, that's how we pronounce it. Mu is equal to negative infinity to infinity of x f of x dx. And then the variance of a continuous probability function is found by going, this is sigma squared, which is the e of x squared minus ex all squared. Now, e of x, like this, actually means mu. So they're the same thing. They're just different part of statistics. But anyway, same thing. So this e of x squared means integral of negative infinity to infinity x squared f of x dx minus mu squared. And then as usual, the standard deviation is the square root of variance. You need to know that. Standard deviation is the square root of variance. Steph, you probably remember this bit. But
Yeah.
as right, you would need to know, you probably just have to start it, so you need to know that. Standard deviation is the square root of variance, and these are your formulas. Yeah. Is it in the formula sheet? Is this part of the formula sheet? Actually, that'll be interesting to know. Let's find out. Financial is that, functions, relations, trig, statistical, there's z-scores. Yeah, there it is. They give you E of x and they give you variance. But they have not obviously given you the more important one, which is the integral. So you have to actually remember the integral bit of it. So integral of negative infinity to infinity of x f of x. Okay. Let's have a look at this. For a particular infant welfare center, the probability density function, PDF, of the age of children brought to the center is given by this. Find the following, correct to 3 decimal places. Let's find the mean. Well, we know that the mean was equal to the integral of negative infinity to infinity of x f of x dx. So we know what f of x is. F of x is equal to 3/4 of x times 2 minus x, right? There it is. So I'll obviously multiply that by x. So 3/4 x times 2 minus x times by x, that gets me that. To find mu, you're just going to integrate that, right? So we're just going to do that here. But it's going to be between 0 and 2. So it's not between negative infinity and infinity because like you actually have it from 0 to 2. That's your average. You're only doing it for those numbers. So 3/4, 0 to 2, and then you should equal to 1. Oh, well, it doesn't, in this case, it equals to 1. It doesn't have to equal to 1. Sorry. It equals to 1. Average, the mean is 1. So one more time. From 0 to 2, x f of x, which is that, 3/4, 2x squared minus x cubed dx. And then you just continue that, and you end up with this result. Any questions there? Okay, find standard deviation. Now, you guys are going to try to do this yourselves. To try to find standard deviation, it was, I'll start you off, it was part of variance first, right? So standard deviation is the square root of variance, but we know variance is expectation of x squared minus expectation of x, which means this becomes the integral of negative infinity to infinity of x squared f of x dx minus mu. Squared, right? It should be squared. Yeah, I thought so. Squared. So you already found average, so you don't need to worry about that. All you need to find now is your new function here to integrate. Well, it's going to be x squared times this. So the integrals are going to be this, from 0 to 2, x squared times 3/4, which I think we can write pretty fast, and write it as 3/4 x squared times x is x cubed, so that becomes 2x cubed minus x to the power of 4. Can we please start from there and integrate this bit, and then let's finish it off and see if we can get an answer out. Let me know if you're completely lost. And if you have an answer, let me know as well.
I got an answer.
Nice. What's your answer?
Got 6 on 5.
6 on 5. Fantastic. So that's variance. And of course, that's for this bit, right? Sorry, no, you just did this bit. You got 6 on 5.
Yeah.
And then you have to go minus mu squared, so minus 1 squared, which is still 1, and that's your variance, and then you got to square root it and pretty much get your standard deviation. Let's see if we can just finish it off now. What about you, Steph?
How would we know what mu equals?
Well, we just worked it out in A, yeah? A was mu.
Okay.
Yeah, that's the idea.
Yeah.
So if the question was ever to just go find standard deviation, you know you need to go actually find the average first or find the mean first.
Yeah.
This is first semester university, just so you know. Literally. First semester university for statistics, which is like literally every course, except medicine, you'll have to do this. So that's why they brought it down now to Year 12, so that it's a bit easier to transition to uni. Azra, you got it out. Straightforward. Steph, done as well?
Yeah.
Yeah.
Yeah, done. All right, let's move on. You can also find the median. Oh yeah, that's nice. Okay, let's see how we want to do this. You can also find the median of a continuous PDF, as should be expected. The median M is the value such that the probability is obviously from x less than m, the median, equals to 0.5, right? Because halfway. So this means you need to set up and solve an equation of the form from 0 to a f of x dx, which equals to 0.5. So a particular continuous random variable x has the following probability density function. There it is. X over 16 for 0 to less than 4 root 2. Find the median. The median must be, write an equation that states the following: from 0 to a, f of x, which is x on 16, dx must equal to, excuse me, 0.5. Now you don't know what a is. A is what you're trying to work out. You're trying to solve for a. So call the upper boundary a, you find a primitive, there it is. You'll solve for a equals to a equals to 4, which means that the median must be 4. Why did that just happen? you're going from 0 to something, right? And it equals to halfway. So usually it was from negative infinity to infinity. So imagine we've got a whole parabola, there it is, negative infinity to infinity. But if you're saying it's from 0 to a, if you're starting from here to here, sorry. You're confusing actually. If you're starting from here to here, it's probably better to do it this way. To let's just say 12, and we work out the probability under this. The probability of this occurring is equal to 1, which means the area under the curve is equal to 1. If you're going to go from 0 to 6, and you're assuming it's 0.5, that means once you work out what 6 is, so once you work out that a equals to 6, that means that is your median. So 6 becomes your actual median. So you got to understand when you're doing this 0 to a business, this a is your median value. So when a equals to 4, median is 4. Okay, that's PDFs done. Now we're up to CDFs, cumulative distribution functions. Be careful, the other one was called probability density function, density. This one's called distribution. Don't say cumulative density function or something. It's cumulative distribution function. In other words, though, we might simplify it to CDF or CDFs. PDFs, CDFs. Okay. Thinking back to that Dirk and his investigation into the plainness of his train to find probability, train less than 3 minutes, he needed to calculate 0 to 3 f of x dx. Yep. And to find the probability that a train less than 5 minutes, you would calculate from 0 to 5. I think we get that. To save recalculating f of x each time a new function, the cumulative distribution function can be defined. The CDF is usually capital Fx. Okay, so CDFs are capital F of x. For Dirk's train investigation, the following would apply. So f of x was this, or after integrating the function, it becomes f of x, which is this. So the cumulative distribution function is the integral of the function. Note that again, because f of x is going to be the integral, which is the area, it has to be between 0 to 1, which means the probability must be between 0 and 1. Okay, I think we should be able to get started so we can actually see this all in play. Do you want to start with this first one? We'll just start with a nice and easy one. Do you want me to do A, or do you think you can just jump straight into it and you know what you're doing? Find the probability density function of this from 0 to 1, 4 decimal places for x being less than or equal to 0.75. Do you want me to do it, or do you girls want to just try it out first?
Could you just show us one?
Sure. So P of x less than or equal to 0.75. This equals to the integral of 0 to 0.75, right? Because it falls within this range or this domain. 0 to 0.75 of 3 on 13 x squared plus 4. I keep my constants on the outside. X cubed on 3 plus 4x, and then it's just a matter of plugging this in correctly into your calculator and writing it to 4dp, which I might just avoid, and we can just look at answers once you guys get them out. So easy? If so, you can start. If not, I'll do another one. All right. maybe just do B and C, and then we'll check our answers.
Okay.
Do we have an answer for B yet?
Yeah.
Yeah.
I got 0.8868.
Yeah.
Yeah.
Nice. And then we're just going to do this one. So 0.25 would be from 0.25 to 1. Just keep that in mind. 3 on 13, everything's the same. It's just from 0.25 to 1. Okay, I've got an answer.
Okay, I got an answer.
Which is?
I got 1.2295.
See, now, and now you know that can't be right because it's greater than 1.
So yeah.
So that can't be right. So you subbed in 1 and then into both of these, and then you subtracted 0.25
Yep.
from both of these as well. All right, let's wait for Azra and see what she got as well.
Yeah, I got the same as you, Sam.
Okay. And yeah, you probably put it wrong into your calculator, Steph.
Okay.
That's really it. So if you want to try it one more time, you can. Azra, if you want to start on question 3, why not try to start that? It says find mean, which was x fx. That's all you need to remember. Standard deviation, x squared fx in an integral, and minus mu squared, minus the average squared. Steph, are you trying to do 3 are you doing C?
I was just trying to get the
Answer.
yeah, for C.
Let's see how you go.
For A, do you just times the whole function by x?
Yeah, that's correct. And then you integrate from 0 to 1.
Thank you.
No problem.
Okay, Sam, I got 0.76.
All right, now you're up to question 3.
Yeah.
So find the mean. The mean is just the integral from 0 to 1 of x f of x, but f of x is this. So you just times it by x, and then obviously I recommend expanding it, maybe leaving this in the outside, expanding this, x cubed plus 4x. And then you just integrate. And that's how you find the mean. Maybe I might just put this x times f of x, and there's your 3 and 13 in the outside. Does that make sense, Steph?
Yeah.
X, f of x. All right, try that. Azra, let me know when you have an answer.
Yeah, I got 27 on 52.
7, no, yeah, same. I got it. That's cool. So that's it, that's mean. Now you got to do the standard deviation, which would be x squared times f of x. And then you integrate that minus this number squared. That's variance, sorry. That gives you variance, and then to find standard deviation, you square root it. So square root that answer. So that's the variance.
I got 51 on 52 for A.
51 on 52. Unless you got the 52.
Yeah.
You wrote pretty much everything I've written, right? You would have had x to the power of 4 over 4
Yeah.
plus, and then that becomes what, 2x squared when you simplify that. Unless you left it as 4x squared over 2.
Okay. Yeah, I needed to simplify it.
And 1 and 0. They shouldn't matter. And then what, you got 3 and 13 on the outside.
Yeah. Alright, I'll type it in again.
Yeah. You don't need to sub in 0. You can just sub in 1 only, because the 0 is not going to do nothing.
Mm-hmm.
So it's just a quarter plus 2 times this.
Okay, yeah, I got it.
Cool. That's 4x squared. 23, 65. So SD equals to this minus mu squared and square root of our answer. You're doing standard deviation now, Steph?
Yeah.
And that's what you get when you integrate. So just double check and same things.
I got for standard deviation root 0.29.
Yeah, 0.3. It's usually 4 decimal places that we write it to for
Okay.
statistics. So it's just a general rule of thumb. Okay. Good job. I mean, while you're waiting, you might as well do this one now, Ezra, from the median. And I'll just remind you, just from 0 to a, f of x, but that equals to 0.5. You're just finding a this time.
I got it.
Nice, nice. Then, well, you might as well do question 5 as well. Why not? Probability density function. There it is. Find the median, and that's the formula. From 0 to a, f of x, there it is, dx, which equals to 0.5. You're just solving for a. Might as well just finish that off. Shouldn't take that long. Azra, you got an answer yet?
Not yet.
Okay.
But I think I did something wrong.
Okay. Do you want to maybe start it again? It's the best way to pick up a mistake.
Sam,
Yes.
I think I'm stuck on this one.
Completely stuck?
Yeah.
Or do you know how to start it?
No. I wrote something down, but I didn't get the answer.
Okay. So what we've got is from 0 to a of f of x. I like using 3 on 13. X squared plus 4 dx. That equals to 0.5. So next line, 3 on 13. Is that okay so far?
Yeah.
Yeah.
That's what I got.
Next line, what did you do? Did you first sub in A or did you get rid of this?
I subbed in A.
Okay, let's do that. I just don't like numbers here if you know you're going to solve for A, but we'll do it. Subbing in 0 is not going to do nothing. This time I wouldn't expand, like I said, you know you're solving for A, so you might as well get rid of this. So 0.5 divided by 3 over 13. Becomes 13 over 6, so you're left with a cubed on 3 equals 13 over 6, and now what are you going to do? A cubed, that's really interesting. How are you going to solve for this?
You get rid of the denominator of 3.
Okay, so you mean times everything maybe by 6, it's probably better. So you times this one by 2, this becomes 624, and then this just becomes 13.
Divided by 2.
Yeah, the only problem is extension 1. Just make sure. I did right. It was f of x. It was 0 to a, right? 0 to a f of x. Advanced. How do I solve this in advanced? Advanced math. Good question. How do I solve that in advanced math? I could do it in extension 1, unless this is an extension 1 question. Not advanced. Definitely advanced. How do I do this one? Okay. Let me pause this recording.